So let us start with peak overshoot. So the response of the second order system to the unit step was 1 minus e raised to minus zeta omega in t divided by root of 1 minus zeta square sine of omega dt plus pi. Now what is peak overshoot? MP, it is nothing but value of the response at peak time minus value of the response at infinite divided by value of the response at infinite. So C of Tp, how to calculate C of Tp? So just put the value of Tp in this equation. Wherever T is there, just substitute Tp. So we get this equation, right? And we have derived the equation for peak time. And from that we got the value of Tp as pi upon root of pi upon omega n root of 1 minus zeta square. So just substituting this value of t here, right? Substituting the value of Tp in the above equation, we get 1 minus e raised to, wherever t is there, omega minus zeta, and then Tp is nothing but pi upon root of 1 minus zeta square. Omega n and omega n will get cancelled and divided by root of 1 minus zeta square into sine of pi plus phi, right? So if you put here Tp is equal to pi by d also, right? The formula for Tp was pi by omega d, or we can write omega d is equal to omega n root of omega 1 minus zeta square. So if you substitute here, that will get cancelled and it will become pi plus phi. Now what is sine pi plus phi? So pi plus phi means what? Second quadrant. So sine of pi plus phi will be sine phi only. Pi plus phi will be third quadrant. In third quadrant, sine will be negative. So sine of pi plus phi will be minus sine phi. And then what you can do from the triangle, right? So this minus minus will become plus. So it will be 1 plus. And from the triangle we have seen sine phi is what? Root of 1 minus zeta square. So just substituting the value of sine phi here. So this 1 minus zeta square and 1 minus zeta square will get cancelled. And finally we will get the value of the C of Tp as 1 plus e raised to minus zeta pi by root of 1 minus zeta square. And obviously when you will substitute the value of t as infinity in the response, it will be C of infinity will be 1. Okay, so it will achieve its 100% in the steady state, let us say. So therefore MP is what? C of Tp minus C of infinity by C of infinity. So just substitute the value, plus 1 minus 1 will get cancelled and MP will become e raised to minus zeta pi divided by root of 1 minus zeta square. If you want percent overshoot, it will be e raised to minus zeta pi by root of 1 minus zeta square multiplied by 100. That's it. Now next is your settling time, right? So what is settling time? So again this is the same response. Settling time is nothing but the final value should be either it should be in 2% band or 5% band. So let us take the case of 2% band. Here if you observe, what is the coefficient of sine means what? Its amplitude, right? So this should be within 2%. So let us take this value. Let us take this value as 2%. So 2% means it will be 0.02, and then if you multiply, okay. So now see here, the denominator is root of 1 minus zeta square. Now let us consider that zeta is less than 1 for underdamped system. So if zeta is less than 1, zeta square will be again far less than 1. So let us say that if it is far less than 1, we can neglect the value of zeta square in front of zeta. So root of 1 minus zeta square will be equal to root of 1 minus 0 will be equal to 1. So this denominator will become 1. And then what happens? Just take log of both the sides, log to the base e on both the sides, and then if you find the value of log to the base e of 0.02, it will be minus 4. So this value will be minus 4. Now what we want this time is nothing but your settling time, because we are calculating this value for 0.02 means 2%. So the time taken will be t will be equal to ts, right? From this if we calculate the value of ts, it will be 4 divided by zeta omega n, right? So or we can say that it will be 4 into t, where t is nothing but time constant of the system, and we can define t as 1 upon zeta omega n. Okay, now let us find the same case will be for 5% tolerance, right? So for 5% tolerance band, the coefficient of the sign, that this value will be equal to 0.05. Now again same way we will equate. Again we can neglect this we can neglect the value of zeta square in front of zeta in front of 1, because zeta square will be far less than 1, and then again we can take log on both the sides and then equate it, and then whatever value we will get, that will be the settling time in case of 5% tolerance band, and this will come as 3 divided by zeta omega n, that is equal to 3t, right? So in this case again the t is nothing but your time constant of the system, right? So these are the parameters, right? Overall parameters. Now so how many parameters we have seen? First we have seen rise time, second was delay time, third was your TP, peak time, then it was MP, and fifth we have seen that is your settling time. So let us solve a numerical based on this time domain analysis of second order system. So for the system G of S is equal to 20 by S square plus 5S plus 4 with unity feedback, find the time domain specifications. Which time domain specifications? Find time domain specifications. Sorry for that. Okay. So when unit input is applied, right? So this is the system. So see, whenever feedback is not given for the system, always consider it as unity feedback. Okay. So this is the system. Okay. So this diagram is given in the question. So we can happily find the transfer function as C of S by R of S, G of 1 plus G of H. Right, so if we apply this formula, if we substitute the value of H is equal to 1, G is equal to this given value, then we can get 20 by S square plus 5S plus 4, and then we can compare with the standard function omega n square by S square plus 2 zeta omega n plus omega n square. So it will be the denominator will be S square plus 2 zeta omega n S plus omega n square, right? So if we compare with the denominator, right, see, highest power of the denominator is 2. So what is the order of the system? 2, right? So if we compare, omega n square will be equal to, yes, so this is your omega n square will be equal to 24. So therefore omega n is nothing but root of 24, so it will be 4.89 radians per second, right? Once you get omega n square, right, you can get 2 zeta omega n will be equal to 5. So 2 zeta omega n will be equal to 5. So once you know the omega n value, you can find the value of zeta, and zeta will be 0.5112, right? As zeta is what? Zeta is nothing but the ratio, hence it will not have any unit. And then you get zeta value, you get omega n value, तो आप omega d आराम से calculate कर सकते हो. Omega d is nothing but omega n root of 1 minus zeta square, and this is the value, right? And then we are having the formulas. Formula for TP is nothing but pi by omega d. So just substitute the value of omega d, it will be 0.747 seconds, right? TR again the formula is pi minus pi by omega d. We have the formula for omega d. We have omega d. We want pi. So what is pi? Pi is nothing but tan inverse of root of 1 minus zeta square by zeta. So the value comes as 1.034. You know the value of omega d. You know the value of pi. So just substitute the values and you can get the answer for rise time, that is 0.501 seconds. Delay time, again we have the formula as 1 plus 0.7 zeta by omega n. So so delay time 1 plus 0.7, right? So 1 plus t. So what is the formula for delay time? 1 second. Formula for it is 50%, right? Yeah. So 50% of the total value. So rise time we have. Okay. So if we find the formula for delay time, right? So it is, if we calculate same like TR, we have equated C of t is equal to 1. If we equate it as 0.5, then we can calculate the formula for TD, and then this is the formula 1 plus 0.7 zeta by omega n. If we substitute the value of zeta and omega n, right, you will get the value of delay time. MP, it is again 100. We are calculating percent MP, so that's why 100 into e raised to minus zeta pi by root of 1 minus zeta square. We have the value of zeta, so we can calculate what is the peak overshoot in percentage. And finally settling time, right? So settling time is nothing but 4 times t. that is 4 by zeta omega n. So it will be 1.601 seconds, right? So like this, numericals based on the formula, right? This numericals will be in the assignment also. So I will soon give you the assignments, so you need to submit it. Okay. So okay, that's it for now. Thank you.